AP Calculus Pretest 10 solutions. Let's go through this. G of 0. Plugging in 0 into my function, that gives me the integral between -3 and 0 of f of t dt. That means I'm looking at the area between -3 and 0, so -3 and 0, and I divide up the area so that this rectangle is 3 by 1, area of 3. This triangle is a 3 by 1, half of that is 1.5. Adding those up gives us 4.5. Moving on to g prime of 0. So the derivative of g gives you just f of t because the derivative and the integral cancel each other out, and you are left with f of 0. So what is the height at 0? That's what this translates to. The height of 0 is 1. How to score yourself? Plus 1 if you give yourself 4.5, if you got 4.5 rather, and plus 1 if you got 1. So that is out of 2 points. On to part B. We're looking for a relative maximum. So relative maximum means we are using the definition of relative maximum, which means that g prime goes from a positive to a negative. And g prime is the same thing as f. So f goes from a positive to a negative. That's what we're really looking for. So where do the heights go from a positive to a negative? At this point, it goes from a negative to a positive. So other way around, nope. This point goes from a positive to a positive, nope. This point goes from a positive to a negative, yep, that's the right one. So it's only at x equals 3, and our justification is because, and you just want to say g prime is positive and goes to a negative. I'm going to say that like this: g prime is positive and it goes to a g prime that's negative. You can write this out in words if you would like. So give yourself 1 point if you have x equals 3, and give yourself 1 point if you have the correct justification out of 2 points. Let's move to the next part. So for part C, we need to find absolute minimum. That means we need to make a table. So we need to make a table. We need our starting value, which is -5, and we need our ending value, which is 4. Now we need to find the critical values in here. Again, we're looking for a minimum. Let's go ahead and look at the graph. So we have a negative area here. So we do need to check this point because this point has more negative than the starting point. So we need to check this point at -4, and then we have a bunch of positive areas. So this point isn't really needed, but we should check this point because there is a little bit more negative area. So we really need to check -5, -4, and then the end point. Going through this. So I need a -4 as well. I guess I can leave that little mark over here. And what is our starting value? We don't have any starting information in here. There would have been something right there, but there isn't. So our start is going to be 0, which means we're just looking for change. So the change is going to be the integral between, and our integral was defined by -3 to x, so it's going to be -3 to -5. But I don't want to do that. I want to go -5 to -3, reverse it, make this a negative. Same thing down here. This gets reversed from a -4 to a -3, make that a negative. This is going to be the regular integral from -3 to +4. And all of these are going to be, our function was a graph of f of t. So I'm going to write f of t in here. f of t dt, f of t dt, and f of t dt. All right, what do these equal? So this is the table that we have, and this is going to equal end. The end value here from -5 to -3, looking at the area, from -5 to -3. So this triangle down here, this triangle is a 1 by 2. So that's going to be times, or 2, then divided by 2 to make it sure that's a triangle. Has an area of 1, it's a -1 really. Finding other area. The area of all of this is going to be a 2 by 1 rectangle, subtracting a circle with radius 1, so that's just going to be 2 minus pi over 2. All right, and then this triangle right here is going to be a -0.5. All right, go away. Go away. Next we have to find what, from -5 to 3. -5 to 3 is going to be, we add these up, it's going to be 1. Oh, that one was a 1 there, I forgot to calculate that. And I actually end up canceling it out by the time I get to this point at -3, so that's just 0. So what about from -4 to -3? From -4, from this point right here to -3 is just 1, and then I need to make it a negative from this side, so it's actually a -1. And then from -3 to 4, so a -3 right here to 4 means I'm adding up all this 4.5 and all this 2 minus pi over 2. So my final answer is going to be 4.5, and then we needed to add the 2 minus the pi over 2, and that simplifies to just 6.5 minus pi over 2. We're looking for the minimum. The smallest one here is a -1, and then we can say that the absolute minimum, it is -1, and it's at x is equal to -4. because this was the x coordinate. Perfect. How to score yourself? Out of 3 points. 1 if you have -4 as a candidate, 1 if you found what the value is at -1, and 1 if you have the justification for why it's the minimum by having the rest of the interval. So having the rest of the table gives you another +1. On to part D. All right, we need to find inflection point. Definition of inflection point is where G double prime sign changes. Sign change. And relative to what that means from our function back here, it's where f prime has a sign change. So where f prime sign change. So we're looking for where the slope turns from a positive to a negative or from a negative to a positive, but the main thing is slope. So slope is positive, switches to a negative, so inflection point right here. I guess I can do this in a different color. Inflection point right here, and still negative slope, turns into a positive slope, turns into a negative slope. We have 3 inflection points at -3, 1, and 2. So we can say that at x equals -3, 1, and 2, and we don't actually need the rationale. I'm going to give it to you. You don't need this. This is because there's a G double prime sign change. How to score yourself? So you get 2 points, and if you have these 3 values, give yourself 2 points. If you got 1 less, give yourself 1 point. If you only have 1 of these, you get 0 points on this, actually, judging by how you grade this on the normal AP test. All right, so that makes a total of out of 9 for this problem. And now on to number 2. So we have this new function, and we're looking for g of -3. G of -3 means we're plugging in 3 into our function. This is going to be equal to 2 times -3, and that's going to be plus the integral from 0 to -3, which is really minus -3 to 0 of f of t dt. All right, -2 times 3 is -6, and then we need to find this area between -3 and 0. So -3 is right here to 0. This radius is 3. Pi r squared gives us 9 pi for the entire circle, or 9 pi over 4 for a quarter of the circle. So we have -6, and then we have to subtract, because this is a minus again, minus 9 pi over 4. All right, now we also need to find g prime of x. G prime of x, that's going to be the derivative of all of this. So I need to take the derivative of this, and I need to take the derivative of this. So derivative of 2x is just 2, and then the derivative of all this, the derivative and the integral cancel each other out, and you're just left with f of t, or f of x rather, because you plug the x in, and this is going to be f of x. All right, and then finally we need g prime of -3, so I'll do that right here. G prime of -3, we're just plugging -3 into the function that we just found. This is going to be equal to 2 plus f of -3, and this is going to be 2 plus f of -3 is the height at -3, so I go to -3, and the height is 0, so this is going to be 2 plus 0, and that's equal to 2. How to score yourself? This is out of 3 points. So you get 1 point if you found this answer, -6 minus 9 pi over 4, and you get 1 point if you found the function 2 plus f of x, and you get 1 point if you found 2. On to part B. This is going to be finding the absolute maximum. That means we have to find a table, and this guy is super hard. This is the hardest problem on the entire test, because in order to find CVs, remember the definition of CV is where g prime is equal to 0. This is the definition of CV. I should write that here. So how do we find g prime equal to 0? We found g prime right here. We need to set this function equal to 0. So we say 2 plus f of x, that needs to be equal to 0. So that implies, if I just subtract 2 from both sides, that f of x needs to equal -2. So this is saying the height is -2. Where on this graph do we have a height of -2? Remember, -2 is right there. The only place, there's no place on the left, the only place that we have a height of -2 is right there. So there's only one x that gives us a height of -2, and that is our only CV. So how do we find that point? So it's a little bit hard, but you can tell what the slope is of this line. You can find the equation of this line and then plug in our y equals 0, or sorry, y equals -2, and then find what that x coordinate is. So I'm going to do that really quickly. So I know that the y-intercept here is going to be 3, so it's 3, and then my slope is going to be, okay, well, I go right 3, and I go down a distance of 6, because I went from 3 to -3. So the slope is going to be -6 over 3x, or just -2x. I'm going to just write that above here, minus 2x. Okay, I'm going to set that equal to -2, because the height is -2, and I'm going to solve for x. So I'm going to solve this, and I'll get x is equal to, what is that going to be, 2.5, or 5 over 2. So that is the CV. So we need endpoints and the CV on our table. So x and then we have our starting point, -4. Our CV is 2.5. That was a really hard thing to find. And then 3. So now we need to do start plus change equals end. Actually, we don't actually have to do start plus change equals end because it's asking for the x coordinate where it's the absolute maximum, and you can tell just judging by our function that we have g prime switches slopes, and you can use that as your definition. I think the table is a little bit easier because we're used to doing the table. All right, so start plus change, and that'll equal our end. I just wanted to point out that there is another way to do it in case you want to do it that way. So start, -4, and I'm plugging that into the integral. -4 times 2 is a -8. 2.5, plug it into 2, so that's going to be 5, and 3 times 2 is 6. And then we need to add all these to the integral. The normal integral is between 0 and x, but this is a negative, so I'm going to do a minus, and it's going to be 0, or sorry, not 0, -4 to 0, and this is going to be plus 0 to 2.5, and this is going to be the integral between 0 and 3. And all of these are going to be f of t dt, f of t dt, and f of t dt. I apologize for the messy handwriting. I'm trying to go fast here. So what is that going to be? So I have a -8, and now the integral between 0 and 4. Okay, so I'm going to have to find the area of each of these little triangles here. So this is a circle with radius 1, so the entire circle has area of pi, so this is going to be pi over 4, but it's negative because it's below the x-axis. What about this triangle here? That's going to be, this is 1.5, and if you don't believe me that that is 1.5, you can use this equation here to verify where x is equal to 0. So 1.5 by 3 divided by 2, what's that going to be? That's going to be 9/2, or 4.5 if you prefer. And notice that we also need 2.5, so 2.5 is right there, and we have to find the area of that triangle. That triangle is pretty easy because that's a distance of 1 right here, 1 by 2, and then divide by 2, and that's just going to be -1, and we need to find that entire triangle, which we don't actually have to find. This triangle mirrors this other triangle, so this entire triangle there, not just this one segment, but this entire triangle is -9/2. It mirrors this first triangle. That makes these a little bit easier to find. So from -4 to 0, from -4 to 0, 9 pi over 4 minus pi over 4 is 8 pi over 4, which is 2 pi, so I can just say -8 minus 2 pi. Again, that negative came from switching the integral here. And then coming over here, this is going to be copied down to 5, and it's going to be plus, we have that 9/2, and then we have to subtract 1 for that tiny triangle right here. And this guy is going to be equal to 6 plus, from 0 to 3, 0 to 3, remember these two triangles cancel each other out, 3 plus, or 6 plus 0. When I simplify these, that's a really small number. This is, if I simplify those, what is that going to be? That's going to be 8.5, and that's going to be 6. Obviously the maximum was at that point. That's our way of proving it with the table. And then finally we want to have our conclusion that G has max, and you don't need to say what the max is, but I'm going to say it anyway, of 8.5, but you do need to say this, at x equals 2.5. Okay, how to score this thing? This thing is out of 3 points. And so you get 1 point if you did all of this work of setting g prime equal to 0 to find what x was. So if you set g prime equal to 0, even if you just wrote that right there, you get 1 point. But doing all the work also proves that you're doing g prime equal to 0. If you found that x was equal to 2.5 after doing all that work, so that's up here, I know it's kind of out of order, then you can give yourself another 1 point because that's a candidate. And then if you found that x is equal to 2.5 and you have your explanation, because either you can talk about the slopes of g prime or using a table. If you have, in this case, the table, that's going to give yourself another +1. All right, on to part C. So we're looking for inflection point. Inflection point is where g double prime has a sign change, and that means that f prime has to have a sign change. So we're looking, sorry, that's super messy, but we're looking for a slope that changes. So let's look for a slope. Positive, 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 and then all of a sudden negatives, negative, negative, negative. There's only one slope change, it's at x equals 0. So it's x equals 0, and then we already have our explanation. It's because g double prime sign change. This is only 1 point, so it's out of 1. And if you have x equals 0, and you also say it's well, it's not +1 there, but you also have to have the sign change. You have to have the x equals 0 and the explanation. Sorry, I'm getting flustered because I'm trying to go super fast. This is going to be number out of 2 points, and let's go through this. We need to explain. We first need to find the average rate. So average rate, this is just the definition that you need to know. Average rate is going to be The fraction is going to be that number minus this number, so it's going to be 3 minus negative 4, and it's going to be the integral of whatever it's looking for. And it's looking for rate, so what is rate? That's going to be f prime, and it's going to be between negative 4 and 3, and I can say f prime of x dx, just filling in what we know. So this is the definition of average rate. So when we do that, the integral will cancel out with the derivative, so you're just left with f. So I'm looking for f of 3 minus f of negative 4, and all that is going to be, using our fraction over here, divided by 7, because it's really 3 minus negative 4. Negatives kiss, it becomes positive. So what is f of 3? Let's come over here. F of 3, if I plug that in, that's negative 3 for the y-coordinate. So it's going to be negative 3 minus, and f of negative 4. Negative 4 is y-coordinate of negative 1. So another negative, negative, all divided by 7. And that's going to be 3 plus 1, which is a negative 2/7. All right, so that's the first part. And then it also asks us why this does not contradict the mean value theorem. All right, so mean value theorem, what is the necessary thing that we have to have in order to use mean value theorem? And one of the things that we need, well, the main thing that we need is that it has to be differentiable everywhere. But look right here, it's not differentiable at this point because it's a sharp corner. And it's also not differentiable there because we have a vertical tangent. So we can't even use mean value theorem because of these two obstructions. So that's why it doesn't, contradict, that's the word I'm looking for, the mean value theorem. So we can basically just abbreviate this. The reason is because MVT can't be applied, and the rationale for why it can't be applied is since, and our function here was called f, since f is not differentiable at x equals, what were our 2 points? It was negative 3 and 0. X equals negative 3 and 0. And that's all you need. Okay. 2 points. 1 point if you had the explanation talking about where it's not differentiable at those 2 points, and 1 point if you have negative 2/7. All right, we're on to number 3. All right, so number 3 means we are looking for relative maximum. Remember, that's the definition where f prime goes from a positive to a negative, and it gives us a graph of f prime to begin with. So we're looking at height here. Where is the height going from a positive to a negative? Height goes from positive to negative there, goes from a negative to positive there, and a positive to negative there. So there's 2 relative maximums. So at x equals negative 3 and at x equals 4, and then we need to justify. So justification is because f prime went from a positive and f prime turned into a negative after that point. And you can say this in words as well. All right, score yourself plus 1 if you have the justification right here, and then plus 1 if you got both those points, negative 3 and 4. That is out of 2 points. Part B, I already know it's going to be out of 2 points. Let me start solving this. Come on. All right, so we need to find inflection points. So inflection point is where f double prime has a sign change. Sign change. And since we are given a graph of f prime, f double prime is the slope. So where does the slope change signs? So it's positive, positive, oh, negative, so it changes there. Negative, negative, negative infinity, better keep going, negative, negative, negative. Oh, suddenly it's positive, 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 and then switches to negative there. Those are the 3 points of inflection. So we want to say at x equals negative 4, negative 1, and 2, and the rationale is because f double prime sign change. How to score yourself. So obviously 2 points. If you got those points, negative 4, negative 1, and 2, give yourself 1 point. And if you have the explanation f double prime sign change, give yourself 1 point. All right, on to the next part. So part C, we need to find all of the intervals where it's concave up. Okay, definition of concave up, use blue here. Concave up is where f double prime is positive. That means the slope is positive, and it has a positive slope. So positive slope means f prime also has to be greater than 0. So again, this is slope is positive and height is positive, since we're given a graph of f prime. So slope and height have to be positive. Let's look for that. Oh, slope and height positive right there, but its slope is negative. Now we're all below the x-axis, so don't even worry about that. Oh, we're above and we're positive, so right there, but now we're negative again. So those are the 2 intervals, between negative 5 and 4 and between 1 and 2. Let's write those down. So we can just write down the intervals negative 5 to negative 4, and we can say, what was it, 1 and 2. And we need to explain our reasoning, and it's because exactly what I just wrote up here, f double prime greater than 0 and f prime greater than 0 on those intervals or something like that. Even this is just fine. Okay, and part D, so we need to find absolute minimum. Okay, that means we're making a table again. So we have our x, we need our start point, -5. Oh, I'm getting a little bit lazy there. -5, and it goes all the way to 5, and we need our critical values. Okay, critical values are where f prime is equal to 0. F prime is equal to 0 there, and there. But we only need certain ones of them. We don't need all of them because we're looking for a minimum. So the minimum, we have positive area, so it's obviously not going to be that point because we have positive all of a sudden. We have this giant negative area, so this is a strong candidate. And then we have positive area, so we don't need this one. We really only need this point at 1 because it's the only one that is preceded by a giant large area of negative. Anything that's preceded by negative and you're looking for a minimum, that is a candidate, and vice versa for a maximum. All right, so we're only looking for -5, 1, and okay, so what do we have a start for this one? So let me think about the start. Go back to the problem. Ah, right there. Okay, so yes, this is the start information. This is the start x coordinate, so when we do our integrals, it's going to be from 1 to whatever, and this is the position, so we're always going to do 3 plus whatever. All right, so again, the start, all of these are going to have a 3, as I just explained, and we need to do plus change. All right, so normally this integral would be from -3, or sorry, not negative, from 1 to -5, but I don't want to do that. It's -5 to 1. I'm going to switch it by flipping it, and that's going to be f prime of x dx. This one is going to be the integral between 1 and 1, so I'm not even going to write this because I know that's going to be 0, and this is going to be the integral between 1 and 5 of f prime of x dx. All right, so now we need to find those, and this is where our shapes come in. This one is easy. That's just 3 plus 0, so it's just 3. This is going to be 3 plus something, and 3, or not 3 plus something, it's 3 minus something, and 3 plus something. So we need to find the integral between -5 and 1. Let's look at the graph. Between -5 and 1. So it's these two circles added up. I need to find the area of the circle. The area of the circle, well, the radius is 1. That means it's pi r squared, so it's just pi, and it's half of pi. So that area right there is pi over 2. This radius over here is 2, so that means it's an entire area of 4 pi, but it's half that, so this is 2 pi. And it's negative because it's on the bottom. So I need to say, what is pi over 2 minus 2 pi? And simplifying our fractions a little bit, that will give us 3 pi over 2. And remember, it's a little bit confusing, but all of those add up to a -3 pi over 2 because the negative one is bigger, obviously. So it's a -3 pi over 2, so it's a double -3 pi over 2. And if I simplify that, double negative makes it a positive, so it's going to be 3 plus pi over, wait, what am I doing? 3 plus 3 pi over 2. 3 plus 3 pi over 2. Perfect. That one's 3. Done with this. I need to find the integral between 1 and 5 now. Between 1 and 5 means I'm starting right here and I'm going all the way to 5. So this entire triangle I can do at the same time is a base of 1, 2, 3. 3 by 2. So it's 6 divided by 2 is 3. And that area down here is -0.5. So when I add those together, I get 2.5. So we can say 3 plus 2.5. And that goes to 5, not an 8, 5.5. And then what are we looking for? Minimum. Which of these is the smallest? Well, obviously this one, because that one has an initial 3 pi over 2, and that one's just way bigger. So that is our minimum, and we'll say that just in our conclusion. Absolute min is 3. You don't need to say, oh, you do need to say it is 3, because you're looking for the minimum, and the minimum is 3, and we'll also say it's, my at symbol, at x equals 1. Perfect. How to score this thing. And we forgot to score C as well. So C was out of 2 points. And how to score, we just need the intervals. So if you have the two intervals, -5 and 4 and 1 and 2, that's 1 point. And if you have the justification right here, that's another 1 point. All right, for part D, this is going to be out of 3 points. And how do you score? So if you have x equals 1, if you just put that right there, it's +1 as a candidate. So +1. And if you have the endpoints right there and there, that's another +1. There and there. And the last thing is that you came to the conclusion that it's 3, and you have the justification either with a table or some other means. That's another +1. Now we're on to the multiple choice. So this is problem number 4, and this is a really hard one in my opinion. Okay, so the left and right sum are pretty straightforward. So if it's a left sum, that means I'm using the leftmost point and guessing what the interval is. Leftmost point, guessing what that is. Leftmost point, and you can see that it's definitely going to be an under approximation for this one. Rightmost sum is the vice versa. This is going to be an over approximation. But the trapezoidal sum, that's going to be the hard part. So trapezoidal sum, what you have to think about is it's a point here, and then it's a straight line between those 2 points that makes your bar. You should see that if it's a increasing function that's concave down, that's the key part, concave down, there's this little sliver up here that you're not accounting for, so that is also a slight under approximation. We haven't covered that formally, but I expected you to be able to draw that shape and see, oh, there is a sliver between those 2 points. So the correct answer is 1 and 3 are under approximations, under estimates. So the correct answer is D. All right, moving on to number 5. So we have water leaking from a tank, and we need to figure out what the total area is under this curve. The quickest way to do this is say, that kind of looks like a triangle, really generally. Maybe it's a little bit over a triangle, so it's a little bit over whatever the area of the triangle is. So base is 10. The height of that is 300. I don't know what else we're doing there. 300. So 300 times 10 is 3,000. 3,000 divided by 2 for the area of a triangle is 1,500. And again, it should be a little bit over that because there's this little shape there, little shape there. So it's a little bit over 1,500. Oh, look, 1,700. There it is. All right, and moving on to number 6. So we have the derivative of this function. So the function can be rewritten as e to the power of x to the negative 1. So when I take the derivative of e, it's whatever it was to begin with. So e to the 1 over x, that's what it was to begin with. And then I multiply by this x to the power of negative 1, taking the derivative of that. So what's the derivative of x to the power of negative 1? Well, I bring the negative 1 down, and I do x to the power of negative 2. I go down a power. So when I rewrite that, that's going to be e to the power of 1 over x, and that's all going to be divided by x squared. And don't forget that negative. And the correct answer is A. Number 7, we have a particle moving here, and oh, these are decimals. We definitely need a calculator. Let's pull that up. All right, so what do we need to do? We need to plug in this, and we need to say, we need to find the derivative. The reason that we need to find the derivative is because acceleration, which we're trying to find, is equal to the derivative of velocity. So we need to plug in this function and then find the answer. So the quickest way to do that isn't even to go into y1, it's just a straight on go math 8, and then I'm going to type in my function right here in my calculator. So it's going to be 7 minus 1.01 to the power of negative t squared, and that's the end of the function. So then I'm going to do comma with respect to x, comma from, oh, it's not from where to where, it's just at time equals 3. So I just plug in 3. And I can just hit enter, and it says that is 0.0546. 0.546. So that's 0.546. And do I have an answer out here? Why? Oh, 0. Did I mess up in my? Oh, I forgot the decimal place. So it should be 0.05 and then rounding 0.55. That's why it's right there. Okay, perfect. Sorry about that. And moving on to number 8, the last question. Again, we're going to need calculator because I have a bunch of decimals, and I'm looking for the instantaneous rate change of c. What is the average rate? Okay, this sounds like the mean value theorem because we have some x equals c, and we're looking for instantaneous rate versus average rate. Mean value theorem states that the instantaneous rate c is equal to the average rate for some c. So definition of mean value theorem is f prime of c is equal to f of b minus f of a all divided by b minus a. All right, so now I need to plug all that in. I need to find the derivative on the left. Derivative on the left, plugging in c for x is going to be, so derivative of x is c. Well, it's not c, it's 1. I don't know what I'm saying. 1 plus, and then 1 over x, 1 over, but it's not x anymore, it's c, 1 over c, and that's going to be equal to, so just making sure where we are going. This is the derivative of f of x, and I plugged in c for x. Now f of b. I need to figure out what that is, and I need to use my calculator for this. So this is a lot of calculator grunt work. Here we go. Okay, so I'm going to actually use a function for this one, and it's going to be x plus natural log of x. X plus natural log of x. Perfect. There. What? No, stop. Okay, so it should still be there. Yeah, there it is. Okay, so I need to say, I need to plug in b. So var's right, enter, enter, var's, yeah. So I need to do b, and b in this case is 4. It's that end coordinate. So I'm going to plug in 4. And then I need to subtract when I plug in 1. So I can actually go like this. I can say y4, and then I'm going to subtract var's right, enter, enter, y1 of 1. And that'll be the numerator. The numerator is 4.386, and then I'm going to divide that by b minus a. b minus a, 4 minus 1 is 3, so I'm going to say all that divided by 3. So what I'm saying right now is 1 plus 1 over c equals 1.462. Hopefully you're able to follow that. You can replay it. It is a video. All right, I'm going to subtract 1 from both sides, minus 1. And now I'm left with 1 over c is equal to this. So 1 over c is equal to 0.462. So how do I solve? I take the inverse of each side. There's a quick way of doing that. I can just hit this button on my calculator, and it takes the inverse, and my answer is C is equal to 2.164. Correct answer is C. Thank you for watching.